Hello everyone. The last topic of this course is relative permeability, and in this set of slides we define the topic and we'll try to solve some examples. So what is the relative permeability? Remember we talked about absolute permeability. Absolute permeability was an intrinsic property of the rock. So it doesn't matter really what fluid you use. The absolute permeability only is a function of the structure of the pores and morphology and the way those grains are basically cemented together. So the absolute permeability is usually measured with a single fluid. Mostly in our cases we use brine or water to measure the absolute permeability, and we basically saturate our core sample 100% with water, and then we try to establish a constant pressure drop fluid flow through the core sample, and then measure the absolute permeability using the Darcy's equation that you can see here. In this case, the saturation of the water is 100%. Now, what if we have multiphase flow system? It means that we have different phases, which are basically water, oil, or we have an oil and gas system, or we have a water gas system, or even we have a three-phase system. So I should mention that when we talk about three-phase system, we mean that all these three phases are moving. So, for example, if you have a reservoir which has basically, let's say, 15% of irreducible water saturation, and the rest is oil, then only oil is flowing. Then in that case, we just consider it is considered to be a single phase, and the flowing equations that are being used to model the flow through porous media will be the single phase equations. Anyway, so now since we have a couple of phases basically in our porous media, then the absolute permeability does not work, because absolute permeability were measured using a 100% saturated core sample, usually with water, right? In that case, each phase will flow differently from other phases. For example, in water and oil system, water will flow at a different rate compared to oil, and therefore they will have kind of different permeability. And that permeability that is different for these two phases is called relative permeability. So relative permeability is the ratio of the effective permeability. So let me define it. So relative permeability is the ratio of, let's say for oil, is the ratio of the effective permeability of oil divided by absolute permeability of your rock. So in this case that I just mentioned, in a three-phase system, water will have its own effective permeability, which is different from the oil effective permeability, which is different from gas effective permeability, right? So if you have these basically permeabilities and you divide it by the absolute permeability of your rock, you get a dimensionless number, which is called relative permeability. So relative permeability for water, you can define it as the water permeability divided by absolute, and the relative permeability of the gas is kg divided by absolute permeability as well. So it's a dimensionless number. It's between 0 and 1, and then we have basically these equations for each specific phase, right? So you can write the Darcy's equation for oil, Darcy's equation for water, Darcy's equation for gas. And please note that in this equation, when you have a multi-phase system, the permeability that you're using in that equation is the oil permeability, effective oil permeability. Here is effective water permeability, and here is effective gas permeability. So these are not absolute permeability in your Darcy's equation when you have a multi-phase flow system. However, in single-phase flow system, we had the absolute permeability in the Darcy's equation. So this is an important difference. And also please notice that you have this viscosity of oil, viscosity of water, and viscosity of the gas inside your Darcy's equation. Now, based on the definition of relative permeability, what you can do is the relative permeability of oil was equal to effective permeability of oil divided by absolute permeability, right? So effective permeability of the oil in that case would be KRO multiplied by absolute permeability. So you can rewrite the Darcy's equation as KRO multiplied by absolute permeability multiplied by area, pressure drop of your oil phase, viscosity of the oil divided by L. So these two equations are equivalent. So if you can have the data of your relative permeability and you have the absolute permeability, then you can calculate the flow rate of the oil in the porous media or water, or basically the gas phase as well. Okay, so that's the definition of permeability. We mentioned this, effective by absolute, right? And these are the definition. So in the next video we'll continue on this topic.